Hey math fans, we're on section 3.2.1. Let's get started. This section is about solving systems of linear equations, and there's two methods we're going to go over in this particular section. So this first method is called substitution, and I'll walk you guys through exactly what it means to substitute. It's where you're solving for either the variable of x or y or whatever you have, and you're substituting that whole entire expression into the other equation to solve. Next, you have elimination. Now, elimination uses a way where we can actually add together both equations, and we're going to effectively eliminate one of the variables to solve for the other one. And again, I'll show you how to do that step by step. So in this first example, it says solve the following system by substitution. So step one, you pick an equation, either one, it doesn't really matter. I like to look for things like if I was to add y to both sides here, I'd be keeping the y and the x positive, and I would be getting an equation here where it's just x is equal to y in this bottom. So I'm thinking the bottom equation is better. Now, once I have one of the equations solved for a variable, I'm going to substitute wherever I see, in this case, it says x is equal to y. Wherever I see an x in the other equation, I'm going to put a y. So let's do that. So that's where the term substitution comes in. So instead of x plus y equals 2, I'm not going to write the x. I'm going to write x is equal to y. So this will become y plus y equals 2. Okay, I'm substituting here. Then I get 2y is equal to 2, and therefore y is equal to 1. And once you've solved for one of the variables, you just can substitute that y equals 1 into any of the original ones. And of course, the bottom one's easy. X is equal to y, so therefore isn't x, if y is equal to 1, won't x also be equal to 1? But you'll get the same answer up here. If you substitute 1 up here, what plus 1 equals 2? Well, the answer is going to be 1. So it doesn't matter which equation you substitute back in, you'll still get the same answer. So final answer. The solution to the system of equations would be 1, 1. Or in other words, that's where the two lines, if we were to graph x plus y equals 2 and then x minus y equals 0, they would intersect at this point right here, 1, 1. Now, would you get the same answer if you were to substitute or use the first equation? In other words, what would happen if I solve for x in this top equation? Like x is equal to, it would be 2 minus y. I could solve for the top equation and then substitute this value in for x into the bottom equation. That would be fine. And I should get the same answer. 2 minus y instead of the x right there. And then minus y is equal to 0. You're going to get 2 minus 2y equals 0. Negative 2y is equal to negative 2. Y is equal to positive 1. And then substitute it back in. You're going to get 1, 1 again. So it doesn't matter which equation you solve for when it comes to substitution. I usually try and solve for the easiest equation possible. Now we're going to use the same problem, but we're going to use elimination. And so elimination means, can you add these two equations together and somehow eliminate one of the variables? Well, let's see here. X plus x will equal to 2x. So I'm just going to add these vertically. Now notice here, positive y and negative y will get me 0. Now, that means it's 0y or just 0, or I don't have to put anything. In other words, right here, this variable has been eliminated. So elimination can sometimes happen just right away. I didn't have to do any work. And that leaves us with 2 plus 0, which is 2. So now I got 2x is equal to 2, so therefore x is equal to 1. Now I can substitute back into either this equation or this equation and solve for y. If I do the top equation, it's going to be 1 plus y equals 2. Your answer is going to be 1, right, for y. Or I'm going to do 1 minus y equals 0. Either way, y is going to be equal to 1 in either of those equations. Your answer is 1, 1. The reason why this is called elimination is, of course, because you want to eliminate one of the variables to solve for the other one. But this one was easy. You didn't have to do any work. So let's find one where you have to do a little bit of work. So here they're giving us a choice. Choose an appropriate method to solve each system of equations, and then you find the solution. I'm a huge fan of elimination, but sometimes they make you work for it a little bit. And take a look at this particular example. If I was to add both of these equations together, I would not get 0 for either x or y. What's going to have to happen is I'm going to need to change by using my properties of algebra to get it to where maybe the x's or the y's will somehow eliminate. I'm noticing that I don't like that 15y. That's going to make the numbers very large. I'm going to stick with the x's. I'm going to try and eliminate the x's. I'm going to multiply the top equation by -3 and the bottom equation by +5. And let me show you why. If I multiply the top equation by -3, I'll get -15x for my first term. Of course, I got to multiply everything else in the top by -3. And then the bottom equation, if I multiply by +5, I'll get +15x. And that negative and +15x will add up to 0. So that's my goal here. Now that I've multiplied both the top and the bottom equation by these two respective numbers, -3 and +5, when I add, I'm going to get 0 for my x term, which means I've effectively eliminated it. So I can solve for y. And I get y is equal to 2. Now what do I do with that y is equal to 2? I can substitute it either into the top equation or the bottom equation. It's up to you. I decided to use the bottom equation, and y is equal to 2. So in the bottom equation, where's there a y? Well, right there. So I'm going to substitute 2 in, and now I'm going to solve for x. And finally, I get x is equal to -5. Now my final answer is going to be -5, 2. Remember, a solution has an x and a y value, but it's also a coordinate point. These are where these two lines will cross. These two equations will intersect at the point -5, 2. And that is also known as the solution. Okay, for our final example, whenever you get a system of equations where they're both solved for y, or for that matter, both solved for x, you really want to use substitution for this. Because y is equal to this entire expression, you're going to want to substitute that in for the other y in the other equation. So this one is solved very easily. -3x plus 4, which is that first y, is equal to the second y, which is 3x minus 2. We add 3x to both sides, add 2 to both sides, divide by 6, you get x is equal to 1. And now you can substitute it back into either of these equations. I'll use the top one. And now I can just solve for y. -3 plus 4, y is going to be equal to 1. Your final answer is going to be 1, 1. And that's going to do it for this section. We'll see you in class.